All right, geometry students, we're trying 7.5 here today. Apply the tangent ratio. We're going to see some new words in these notes today, some things we've probably never seen before. So we're going to start what we're calling trigonometry. Okay, maybe you've heard of it before. Sounds big, right? What we're looking at least in this chapter, is trigonometric ratios, and that is a ratio of the length of two sides in a right triangle. So we're going to use those right triangles that we've been starting here in chapter 7, and we're going to start talking about the ratio of the sides, okay? Now, we could do different sides because we have two legs, right? When you have a right triangle, you have a leg here, and you have a leg here, and you have the hypotenuse here. Okay, so we need to remember that we have those three sides of every right triangle. They can all be different lengths. They can never all be the same length, not in a right triangle. So sometimes you have two of the legs that are the same. Of course, the hypotenuse is always the longest, okay? So we're going to start just today with just the tangent ratio. And the tangent is the ratio of the lengths of the legs. So what we're going to deal with are talking about the legs, okay? So it is so important when you are dealing with any of these trigonometric ratios that you start with understanding what angle you're coming from. It's all about the angle you come from. So you can't just look at the picture and go, okay, I'm going to go from here. You need to mark it. You need to go to that angle because everything is in relation to that specific angle. Okay, so let's start first with our rule here for tangent ratio. It says the tangent ratio, let triangle ABC be a right triangle, remember right triangle, with an acute angle A. And the tangent of angle A, written as tan A, you're going to see that abbreviation TAN, is defined as follows. The length of the leg opposite A, which when we come over here to A, the leg that is opposite over here, okay, is CA, or no, it's not, it's CB. And then the leg adjacent, which is this one right here, which is BA. The order of your letters doesn't matter. All right, so just a quick reminder. So tangent, I'm going to use a little different symbol here, of an angle, okay? That's a Greek letter theta. It stands for an angle. That's all it is. So tangent of some angle is always going to be the ratio of the leg opposite over the leg adjacent, okay? Tangent equals opposite over adjacent. That's what we're going to work with. Now, before we go to our actual example here, I really need you to get this margin note down, because sometimes we get confused when somebody's like, wait, that's not what I got. Well, you have to stop and think. In the same triangle, there's two different tangent ratios, okay, because there's two different acute angles. So each one of those angles will have its own tangent ratio. So as it says, there's one for each acute angle. And this is so, so very important, okay? You can never have a tangent for the 90-degree angle. We never go to the 90-degree angle. The only thing we go to is those other two acute angles. We do not use the 90-degree angle, okay? So a couple of things before we start. We are going to use our calculator a lot. You need a calculator for this lesson. And we are going to use buttons on our calculator we haven't used before. If you look at the middle of your calculator, at least the ones in my classroom, there's three buttons, SIN, COS, TAN. We're going to use the tangent button today, which is the TAN button. Okay, so quick note, you don't have one of my classroom calculators, but you have your phone handy. Your phone's calculator, if you turn it sideways on most smartphones anyways, you can find this tangent button as well, okay? Usually you have to turn the phone sideways to find it. Now, one of the key things, though, that I need you to be careful of when we go to use the calculator is your calculator needs to be in what we call degree mode, because our angles we're going to talk about today are in degrees. So on my calculator, if you're going to go in degree mode, up at the very top underneath the screen beside the second button, there's a button, the DRG. I call it the dirge button, DRG. When you push that button, you have three options, okay? It says DEG first, that stands for degree. It says RAD second, that stands for radians. And then it says GRD at the end, which is gradients, okay? Now, I do need to warn you, my pre-calc is using radians a lot right now, so sometimes they are switching the calculators when they use them to radians. We are only going to use degrees, so make sure that the underline on my calculator is underneath the degree and hit enter. And then at the bottom of the screen on my calculators, you can see the DEG. Okay, a few of you have a calculator that maybe just has a little letter D down there when it's in degree mode. But if your calculator is not in degree mode, it needs to be changed to that, or you're going to get all wrong answers. Okay, so it will make a difference in the answer they give you depending on the mode. Okay, for what we're going to start with here, the calculator, it doesn't matter which mode it's in, you can just use it. But as we go through our notes, we are going to need that degree mode. So let's talk first about this tangent. So notice, and this is so important to see, that the first one they want us to start with is tangent S. So the S is the angle, that's where they want us to go. So you go to the angle and you start right there where you're at, okay? So when I find tangent of an angle, it's always about the opposite over the adjacent. So I look at where S is, and I go opposite the S, and I see side TR there, okay? And adjacent is the leg. It's all about the legs, okay? Legs only today, guys. Legs only, okay? So this is my hypotenuse, okay? So I can't go to the hypotenuse because I need a leg. So this is the opposite leg, okay? And then the one that touches the angle is my adjacent leg. And that's the one I want to put next for down here on adjacent. Opposite over adjacent, okay? Every time. And the more you write this down, the more you remember it. Tangent of my angle S is opposite over adjacent. Okay, let's put some values to that. My opposite leg there is 60. My adjacent leg there is 25. And just like any ratio we've looked at in the last few chapters, reduce, reduce, reduce. Okay, what can I divide both of these by? 5. So I get 12 over 5, and that's as small as I can go. That is my tangent ratio as a fraction. So it said write it as a fraction. Now as a decimal rounded to 4 places. Just on your calculator, 12 divided by 5, doesn't matter the mode. And I get 2.4, but it said 4 decimal places, so I'm just going to add 1, 2, 3 zeros. Okay? And you're going to see as we work through this, we're not going to need it a lot this section, but as we finish out the chapter, those 4 decimal places are going to be really important. So the more we get in the habit of that, the better it is. Okay? All right. So we found the tangent of S. It's either 12 over 5 or 2.4000. So now we're going to be in the same exact triangle, and I'm going to go to angle R because now I'm finding tangent R. So I need to go to angle R. Everything I wrote before doesn't matter because that went to S. Now I'm on R, and everything goes to R. So from R, my hypotenuse is still the hypotenuse. That does not change ever. But when I look at R and I say which leg is opposite, now my opposite goes across, and my new opposite is ST because I'm at a different angle. The leg that's adjacent or touches is the one that angle R is touching there is TR. So they actually switched places here. Okay, so opposite R is 25, and adjacent to R is 60, and like any ratio, we need to reduce it to lowest terms. So divide both of them by 5, and I get 5 over 12. All right, very different fraction when I flip decimal when I flip that fraction, 5 divided by 12. This one definitely has 4 more decimal places, 0.416, and I'll round to 7 now. Okay, so each acute angle has its own values, and you have to look at the angle you're at to find the adjacent and the opposite, not from what you've already marked. You can't mark a triangle up before you start because your angles, as your angles change, your opposites and adjacents change as well. The one thing that never changes is your hypotenuse. All right, so let's go to page 2. We're going to do the same thing here on the top that we just did on our last one. They want us to find the tangent of B and then the tangent of A. We're going to write them as a fraction in lowest terms and as a decimal rounded to 4 places. So we're going to start at angle B. Okay, so tangent, don't forget, I'm going to write it again, equals opposite over adjacent. Always the legs. Okay, so by the way, I'm going to mark my hypotenuse here so I don't use that because I don't want to get confused. Okay, so tangent B is going to be the opposite. So I go to my angle B where I'm at and I go opposite that. That's 48. Over the adjacent leg, well, I can't go to my H, so it's the leg that I'm touching, which is 14. Always see what you can do about reducing. I think 2 maybe? Maybe that's all. 24 over 7. Yeah, that's all. I'm not going any smaller than that. All right, so 24 over 7 for tangent B as a decimal. 24 divided by 7 is 3.4286. All right, same triangle. This time I'm going to find tangent C. So it's all about the angle I start with. So tangent C. I go to C over here, and from C, my hypotenuse is the same, but this time C's opposite is 14. C's adjacent leg is 48. I don't use the hypotenuse. I divide by 2, and I get 7 over 24. Again, my decimal becomes very different because I flipped my fraction, and I get something about 0.2917 when I round that. Okay? So in one right triangle, we have 2 different tangents. Never, ever, ever do you do the tangent of the 90. It doesn't work. Okay? Just to reinforce that, because if we've taken our calculator and we've put it in degree mode, go ahead and just type in tangent, hit the tangent button, hit 90, and hit equals. What'd you get? An error, right? So that's a quick reminder. You can't take the tangent of 90. You get an error every time on your calculator. So don't try to find a tangent ratio because it doesn't work, okay? All right, so this is what we're going to find. So every time you have a triangle, like the one on the right here, that has an angle of 31 degrees, if you think back in chapter 6, all my triangles that have angles of 31 degrees, the angles are congruent, but the sides are proportional. Sides are proportional. Means I can take my sides and put them in a ratio. And when I put something in a ratio, I can reduce it to lowest terms. So I have this 31-degree triangle right now, but every triangle with a 31, every right triangle with a 31 degrees, all their sides are always in the same ratio every time. And that's why what we do is our tangent ratios are this big group of ratios that somebody came up with, not because they came up with them, but because they were always the exact same numbers. And they put them into this chart, and the chart got programmed into our calculators, and that's what it's kind of figuring out. So what this triangle is saying is if I have a 31-degree angle, the sides are always in the exact same ratio every time I have a 31-degree angle. So if I know what that ratio always is, I can find my missing side. And that's how we're going to use this. So once again, make sure your calculator's in degree mode, okay? If you don't happen to have a calculator, but your textbook's there at home, in the back of your book, page 925, there's a whole chart of tangent values, and you can use those. It's just a lot harder to use them, but you can, okay? It's easier to use a calculator. So we can't forget that tangent of any angle equals opposite over adjacent. And that ratio over there is always a set number because all angles of the same measure have the exact same ratio. Okay, so this is what we're going to use. Tangent of an acute angle to find the leg length. Tangent equals opposite over adjacent. Okay, I look at my triangle, I have this 31 degrees. Well, opposite my 31, don't forget this is the hypotenuse, so I'm never using that. Opposite the 31 is 17. Adjacent to the 31 is x. So I have the tangent of my 31 degrees equals my opposite over adjacent, 17 over x. I'm going to solve for x. So to solve for x, first, I can never solve for a variable when it's in the denominator. It just can't be done. I have to get that x out of the denominator. How do I do that? Well, I multiply it by it. What I do to one side, I have to do to the other side. So I'm going to end up with x times the tangent of 31. On this side, they cancel, equals 17. Now, my job is still to get x by itself. What's connected to x? The tangent of 31. So how do I get rid of that tangent of 31? I divide by that, okay? So what I do to the one side, I have to do to the other side. So I get 17 divided by tangent of 31. Now, notice I haven't gone to my calculator yet. I'm just writing this down. Okay, I'm going to stop right at that spot and put a box around it because that's what I call my standardized test answer, okay? When you take your ACT, when you take your SAT, they tell you all the time, you can bring a calculator and use it on parts of it. But then they're going to tell you, too, that you can technically take their whole test without a calculator. Well, if you're going to do a question like this on the SAT or the ACT without a calculator, you can't finish it. Because what that tangent of 31 is this great big long decimal. If we found it on the chart, it's 4 decimal places. We can't see the program in our calculator, but it goes to infinite number of decimal places. It's this huge decimal, okay? So we don't know that in our brains. We don't memorize those. We don't have a chart when we go into these tests. So on these standardized tests, they stop the problem right there. If it's a multiple choice question, they're going to leave that answer just like that. The answer choice you would pick would be 17 divided by tangent 31. So you're going to hear me call it my standardized test answer. So there's my standardized test answer. This is the first time I'm going to go to my calculator now. And I'm going to type in my calculator exactly what you see. 17 divided by tangent. And they give you a little parenthesis for 31. I close my parenthesis and I hit equals. And I get about 28.3. Okay. Now, one thing I wanted you to notice I put down 1 decimal place. Kept talking about 4 decimal places, okay? On your final answer for the side of a triangle, I like this decimal 28.3, okay? 1 decimal place is fine for the side length, okay? Go back to your calculator and hit tangent of 31 just by itself, okay? And when I hit tangent of 31 in my calculator, I get 0.600. I'm going to round it to 9, okay? So if I didn't, then by the way, that's the same number that'd be in the back of your book in that chart. So let's say I don't have a good calculator that has the tangent on it. So now I find that number in the back of my book on the chart. And so I go 17 and I divide by 0.6000, or only 2 zeros, right? 9, and hit enter. I still get that 28.3. In your work, the work needs to have 4 decimal places. In your final answer, you're welcome to put just 1. I'm just curious, 17 divided by 0.6, and I get 28.3. This one is very close because of all those zeros. It doesn't make a difference. But on some of them, it'll make a big difference in your answer. Okay, so let's go down to our real world problem. For those of you planning on visiting a lighthouse soon, I know you're always curious how high that lighthouse is. And unfortunately, your measuring tape does not reach all the way to the top. Nor maybe can you climb all the way to the top. So, what's a way we can measure the height of a lighthouse that's been standing there for a long time if we can't climb it, we can't take a measuring tape all the way to the top and measure to the bottom? So, one of the things, and you've probably seen these used in a different manner, but it works the same way, is if you've ever seen surveyor's equipment, okay? A surveyor might be out in the road, out in a field or something. They look like they're using a little camera, okay? And they are using this device that actually can measure different angles and kind of uses a laser beam so you can do a laser. So what we can do here is we can set our camera out over here in the corner. Okay, so my camera's over here, and I measure exactly how far I am from the lighthouse. So I'm 100 feet away from the lighthouse. So I must have a measuring tape somehow, right? But then I set up my little camera, and I tell it to keep going until the little laser hits the top of the lighthouse. When the laser hits the top of the lighthouse, I find out that I'm at 62 degrees from the ground is the angle that my camera or the little device needed to look at so that I could see to the top there. What I have then, because my lighthouse is standing nice and straight, is a right triangle. And on that right triangle, I have one angle beyond the 90-degree angle and one side. So I'm going to use tangent of an angle, okay? I'm going to use my theta just to stand for my angle equals opposite over adjacent. So what angle am I at? What's the measure where I'm at, okay? So my angle that I know is 62. So I'm going to write down tangent of 62. And now everything goes from the 62. So from the 62, I go opposite and I see my H. I go adjacent and I see 100. And remember, this one is my hypotenuse and I don't use that. All right, time to solve for H. I want to get H by itself. Now be careful this time. Is H in my denominator? No, I don't have to. So I just look at where H is at. I actually like where H is at, But the problem is it has 100 still connected to it. How's 100 connected to it? By division. How do I get rid of division? I multiply. So multiply both sides by 100, and this side will cancel. This side will become 100 times the tangent of 62 degrees. That equals my h. That's what I call my standardized test answer. That's what would be my answer choice on an SAT or ACT question. But we have a handy-dandy calculator. Let's go ahead and use it. I'm going to take 100 times, notice this time no division because it's side by side, 100 times tangent of 62 degrees. And I get 188.1, okay? It says to the nearest foot, so I'll just round it to 188 feet tall. Okay. So we can use this rule of tangent ratios and such to figure out where we're at and something that's so tall that we can't go up that high or something to that effect. Who knows, maybe we can replace our cardboard square, right? Okay, last page of notes, okay? And we're going to do something a little bit different than what we've seen before. It says use a special right triangle to find the tangent of a 30-degree angle. And I believe I added in your notes in simplest radical form. Okay? So, they didn't start us with a triangle. I mean, you can look down here and you're like, oh yeah, they did start us with a triangle. But if or when I put this on your test, I'm not going to give you a triangle. I'm just going to tell you that I might write that exact same question. Use a special right triangle to find the tangent of a 30-degree angle in simplest radical form. Maybe that's all I give you. So if they don't give you a triangle, draw one. Okay? So I draw a right triangle. And they told me a 30-degree angle, so I do my 90 degrees. I have my 30 degrees over here, which leaves what for the last angle? 60. All right, now, they didn't tell me anything more about this, so I need to label the sides. So if you get a choice to label the sides, you're going to label them any way you want with any set of numbers, as long as it follows the 30, 60, 90 rule. Okay, quick reminder on my 30, 60, 90 rule. So my 30 is my short side across from the 30, across from the 90 is my doubled side, and across from the 60 is my x radical 3 side. Okay, so you get to choose. And normally I would say, okay, what are you going to call the smallest side? Because that's the smart one to choose, and then you figure out the rest from there. Okay, well, on this particular problem, the book chose our one for us. And we're going to go with it to start with so you can kind of see. You'll see at the end why they chose this. And over here, on the shortest side, they decided to make it radical 3. Seems like a natural number, right? Okay, so if that side's radical 3, we need to find the other two sides. Across from the 30 is the shortest. They called it radical 3. So across from the 90 doubles it, so it's going to be 2 radical 3. And across from the 60 is going to be my radical 3 times radical 3, right? My side shortest times radical 3, well, that makes radical 9, which equals 3. So I find this short side, or longer side down there is 3. Okay, so I have 30, 60, 90, short side's radical 3, multiply by 2 to get the hypotenuse and make it 2 radical 3. Take my short side of radical 3 times radical 3 and get square root of 9, which equals 3 for the bottom. I think I'm ready to find the tangent of 30. Okay, so I go to my triangle, I go to the tangent, or the 30-degree angle, because that's what it's talking about. And from my 30, I want to find the opposite radical 3 over the adjacent. Remember, no hypotenuses. I want the leg and not the hypotenuse over 3. So my tangent of 30 is radical 3 over 3. Okay? Now, let me tell you a quick secret. Every 30-degree angle has a tangent of radical 3 over 3. Always. Always. So if I ask you on your test question, what's the tangent of 30 degrees? The one and only answer you can give me is radical 3 over 3. If you give me a decimal, I will mark it wrong. I want the simplified radical answer, and that's going to be radical 3 over 3. Okay? Now, just kind of so you know too. Let me do one more. What if I ask you for the tangent of the 60-degree angle? Okay, so we draw the triangle, and we have a 30, and we have a 60, okay? And I can use what they have over here, radical 3 here, 3 here, 2 radical 3, okay? If I say find the tangent of the 60, okay, so here's my 60, opposite my 60, so remember tangent of 60 or tangent of anything is opposite over adjacent. So my tangent of 60 equals, opposite is 3, adjacent leg is radical 3. Am I allowed to leave a radical in the denominator? No. So I would multiply by radical 3 on the bottom, and what I do to the bottom, I do to the top. So on the top, across the top, 3 times radical 3 is 3 radical 3. Across the bottom, radical 3 times radical 3 is radical 9, which equals 3. And the only thing I can simplify is outside numbers. You can't go in and out. So 3 divided by 3 is 1, and I get 1 times the radical 3. So the tangent of 60 is radical 3. The tangent of 30 was radical 3 over 3. Okay? By the way, if I happen to ask you the tangent of 60 degrees on the test, the answer is radical 3. Always will be. Every day for every 30, 60, 90 triangle. All right, so let's look at a couple more here. On number 2 down here, it says find x, and we're going to round to the nearest tenth. Okay? So I notice x is one of the legs on my triangle. I have an angle on my triangle, and I know the other leg. So I go to my angle, and opposite that is the 13. The adjacent leg is x. And it looks like I could do a little tangent work. The tangent of 63 degrees, always the angle there with the tangent, equals the opposite, which is 13, over the adjacent, which is x. All right, can we solve for x when it's in the denominator? No. So we multiply to get it out of the denominator. Now I have x times the tangent of 63 equals 13. How do I get x by itself? Divide by tangent of 63. So what is 13 divided by the tangent of 63? I get about 6.6. Again, in my work, I need to work with 4 decimals if I need to do something with decimals, okay? But if I'm using the calculator, it takes care of it for me. So remember, the 13 tangent divided by tangent 63 is my test answer, and the 6.6 is this answer for this x right here. Same idea. Let's look at number 3. I want to solve for x. Well, where's x at? Well, it's across from this 59-degree angle. It's opposite the 59. By the way, the hypotenuse is down here in the bottom. And then closest to this is the adjacent, which is 21. Your hypotenuse never changes, but your opposite and adjacent will switch depending on the angle you're going from, okay? So to solve for this x, I'm going to start with my angle, and I get tangent of my angle, which is 59, equals my opposite, which is x, over my adjacent, which is 21. I'm looking to solve for x. X is not by itself. Is x in my denominator? No, it's in the numerator, and that's a good spot for it. We don't need to move the x. The only time you move the x is when it's in the denominator. So my x is in a good spot, but I need to get it by itself. What's connected to x right now? 21. What do I do to move 21? It's being divided by 21, so I do the opposite, and I multiply by 21. I have to multiply both sides by 21 to keep my equation equal. The 21s on this side cancel, and I'm left with x. And on this side, I get 21 times tangent 59. It's not good when I run out of space here. Okay, so in my calculator, I'm doing 21 times the tangent of 59. And I get about 34.9. So my missing x over there is 34.9. And I find that using my tangent ratio. All right, last one here. In example 4, that's the one at the top of the page, suppose the length of the shorter leg is 1 instead of radical 3. So again, I told you, if you do a 30, 60, 90 triangle, I'm going to often leave it that you get to choose what you call the short side. So up at the top, the book called the short side radical 3. This time the book says, what if we called the short side 1? And I'm going to be honest, guys, that's what I normally call it. I just make it small, I make it 1, and then I find out the rest of my sides. Okay, following my 30, 60, 90 pattern. If across from my 30 is the short side is 1, I double that for my hypotenuse, so my hypotenuse is 2. And I go back to my short side of 1 and take it times radical 3 for my long leg. So across from the 60 is radical 3. Okay. I'm going to find the tangent of 30 again. So starting here, tangent of 30. Now it tells me I go to my 30-degree angle because that's the angle. And from the 30-degree angle, I want its opposite, which is 1. And I want its adjacent, by the way, that's the hypotenuse, so I want the adjacent, which is radical 3. Okay? All right, we have opposite over adjacent. Is that a good way to leave my answer? No. No radicals allowed in the basement. That's a scary monster in the basement. Can't leave it there. Got to get it out. How do I get that radical 3 out of the denominator? I multiply by radical 3. And what I do to the denominator, I do to the numerator. So across the top, 1 times radical 3 is radical 3. Across the bottom, radical 3 times radical 3, square root of 9. Well, what's the square root of 9 equal to? 3. Can I do anything more? One number's inside, one number's outside. I cannot simplify. I am done right there. Tangent of 30 degrees equals radical 3 over 3. Wait a minute. Quick check. I just got tangent of 30 equals radical 3 over 3. Go to the top of your paper. What was the tangent of 30 at the top? Oh, look. The tangent of 30 was radical 3 over 3. Didn't we? We got that earlier. We're getting it now, but we had different lengths on our triangle. Does it matter? No. Everything simplifies down to the exact same thing every time on a 30-degree angle. So you should always get the same answer. So if this question's in your homework tonight, you should know that tangent of 30 is radical 3 over 3. It's always going to be. Okay? All right. You need to practice this. See if you can get comfortable on this, okay? So you have page 469 to 470 in your book, 3 through 29 all, and show all your setups and work. That's so important to show those so you know how to do this. As we learn more of this in more of our ratios, more of our trigonometry, it's not hard, but it is going to be tricky, and it's going to seem really hard if you don't practice it. Okay? All right, let me know if you have any questions.